learning about the significance of satellite imagery. I think that is the very core of this session. Like, we will be introducing of the very fundamentals of satellite imagery, and you will also discover alternate geospatial products within this session, and we will be talking a bit about Google research as well. So yeah, let's dive into satellite imagery 101. So there are various types of satellite imagery one can use, and it really depends on your particular use case. But the basis of having predominantly to run the Earth observation sector, of course, it has strategic as well as economic and as well as climate use cases. We primarily see, for the most part, but there are various different types of satellite imagery which we will be exploring. For example, there's infrared, of course, is for thermal imaging, for land surface temperature, for example, and of course, also a different type of satellite imagery called SAR imagery, which is synthetic aperture radar. So a big, you could say, con of optical imagery would be, what would you do if it's nighttime, right? So there exist various other sensors, such as SAR imagery, which can actually, it can also emit a different, if it's cloudy, for example, so optical imagery would deem is also a very big challenge in terms of optical imagery. So SAR imagery, of course, this type of imagery is actually quite expensive. So some of these imagery is open, can actually go upwards of single tile, going upwards of $10,000 per tile. Even hyperspectral imagery, if we would talk about it. So primarily satellite imagery is on the electromagnetic spectrum. So our eyes can see the RGB spectrum. So the visual thermal imagery is towards the near infrared section of the electromagnetic spectrum. So hyperspectral imagery is basically the combinations of all these particular electromagnetic spectrums. The imaging of a certain area of interest would be hyperspectral imagery. Yeah, so moving on. So I will be using these terms, of course, in this session. So a spatial resolution, for example. So we've all seen, we've all used the word in terms of different images, or for example TVs, or for example the 8K or 4K resolution TVs, right? So in the context of satellite imagery, spatial resolution is basically if you see an image, right? So 1 pixel denotes the area on ground. So if a spatial resolution image of 30 meters, for example, so a single pixel on that particular image would denote 30 meters on ground. So that is the spatial resolution. Temporal resolution is also a very crucial element when you're working with satellite imagery. It is basically, let's say, for example, today is the 28th of February. So if you would take a satellite image of, let's say, New York, for example, on February, so what would be the revisit of that particular area, Central Park, let's say 10 days or 5 days? So the revisit cycle of that area of interest is actually called the temporal resolution. So some satellite images, it really depends on the constellation of satellites or Earth observation. Some temporal resolutions are as low as 5 days, some could go up to 16 days, and some go daily. So it really depends on how many different satellites are in a single orbit or in a constellation, frequency of the revisit cycle. So this is very important. So as late 70s, we have something called as the Landsat series by NASA. This is an open source, you could say, satellite image. So this is at 9. So Landsat 1 was launched way back in the 1970s. So we have actually dating back to 1970s to present time. So this is a very crucial element when you're working on satellite imagery. So let's talk about some applications. I would argue that satellite imagery and cross sections with every industry that you can throw at me. So from supply chain to natural disasters, to oil and gas, to mining, you can have cross sections of satellite imagery. So many different industries. It's quite astonishing. From real estate, intelligence, and so on. I've listed a few over here. Agriculture is a very important aspect. Security is also an element that very crucial in our times. Climate change is of course affecting different crop cycles all around the world, and comes in different types of satellite imagery comes in for just that. So we've all used Google Earth. So how many of you over here has actually, tell me in the chat? Yep. So yeah. Okay. So lots of people over here have actually used Google Earth. So let me just share my screen right here. So the best you could say. So the best way to access satellite imagery on the go would be Google Earth, right? So this is Google Earth Pro. You can actually also the moon actually, or different planets as well. So the craters are also let's switch back to Earth, because in the Earth observation industry, so let's go right back. You can actually view also the constellations as well. So it's quite interesting. So let's see where my campus is, for example. Right? So this again is the best way to view satellite imagery, and that on different temporal scales that I mentioned. So this particular area is where my university is. So over here is the National Space Agency of Pakistan, actually. So this image is from November of 2023. So the latest image is from April of 2024.
Right.
And yeah, is someone asking a question? All right, never mind. So you can actually go back, way back to, let's say, 2013, and you can see this particular block. This is where my department is currently. So this is the current image. Is not here. So this is from 2017. Let's go back to 2008. You can actually see your particular area of interest temporally, how urban is, for example, expanding. Let's move on to another place. This is where I live currently, and let's move to the latest image. And I'd like the audience over here to focus on this particular house over here, right? And this is a gated community here in Islamabad, and you can see first how urbanization is a real thing. You can see it way back in 2016. There's a bit of development. Let's go way back in 2003, and whoa, you can see over here there was, you can see this lake is probably like a few kilometers wide, and you can see this particular house is here, and this gentleman is living in the middle of nowhere. I have no idea how, but somehow in 2005, he's living here. I do commend his determination, and you can see how a private real estate developer acquired all the land across this particular area and started housing societies. And you can see how urbanization is affecting. So you can utilize satellite imagery to determine if let's say my plot of land is actually feasible to build houses on. For example, over here, so you can see there's cloud cover here as well, as I was mentioning earlier. There's also you could say a challenge. So there are different cloud masking algorithms to optimize different satellite imagery to lessen the blur or the cover of clouds. So that's also a bit of GeoAI in terms of vision models. But we will be focusing on LLMs later on. So yeah, over here, this particular area, as I mentioned, this is this right. So a real estate buy a plot of land over here, or this particular cloud cover is a plot of land over here to my house, for example. So it basically you're at risk of having your house sink down. So you can actually utilize satellite imagery, open source, to actually make sound real estate decisions. So yeah, so let's go back to my farmlands. I also here in the central regions, Punjab here in Pakistan. This is the latest satellite imagery, and let's go to 8. Oh, so this is actually a grayscale. So a grayscale image is also a part of different satellite imagery types. So this particular image is from again, this is from 2008, but the series, if I can't see over here. If you can see over here, wait, yep, you can. So this particular image was provided by Maxar. So Google actually acquires different images from private organizations as well. So different organizations like Maxar, Planet, Airbus, they actually have images for sale. And as I mentioned, some of these tiles from private companies can go upwards of 100,000 US dollars, hyperspectral imagery, to let's say an optical image could go, or a SAR image could go upwards of $10,000 per image tile. Let's move on to a very unique area of interest. This is in Iceland. And whoa, you can see over here, there has been a volcanic explosion. So if we went back to 2016, if you come back to 2019, you can see these particular areas, like, probably dinosaurs used to roam around or something. And then you can see, okay, a bit of cloud cover. You can see how the different terrains are moving in how Mother Nature is like boiling up. So yeah, so this particular area is now, it is getting angry. So Mother Nature is getting angry. So I think in the April of 2021, this particular volcano erupted, and you can see how this particular image tile has able to capture volcanic ashes. So what if I told you that you can actually, using satellite imagery, detect different atmospheric pollutants and different concentrations of atmospheric pollutants using satellite imagery? So this is pretty cool over here. Let's move to the latest image, and you can see how the molten lava has flown all the way to this main highway, and probably potentially it could go flow down to the sea. I don't know the current status here in Gildingadare, but nonetheless, it's quite interesting. So again, to have an overview, this is the fastest way to access optical satellite imagery for various areas of interest. Yep. All right, coming back to the slides. So we just explored stories with different satellite imagery, and we will now be moving to the Google Maps platform. So up until now, do we have any questions?
Yes, I'll read it for you. The question is from Sergey: is it also possible to go back in time through the data history in the free version?
On the Google Earth Pro, there is limited usage in terms of what historical data that you could move back towards. Some areas, I think I was like playing around London. There are optical imagery way back to 1940s as well. So during the World War, there were certain images that were acquired by different fighter jets. that has been published and also acquired by Google, and they're onto the platform. But again, for the most part, temporally, you can see a few decades, for example, on Google Earth Pro. But again, nothing too precise in terms of, like, this particular month or this particular day, for example. For that, we will be stepping up. That's the Google Earth Engine we will be talking during this session. So to answer your question, Sergey, you can go back and, but not to very specific timelines. But for the most part, Google just provides different optical imagery, again, which is internal stuff back then. But for the most part, you can go back a few decades, a few months. All right. So let's proceed. Right.
Yeah.
Right.
Thank you. Hi,
So yeah. Yes.
hi, Ahmed. So the pinpoints you have placed on Google Earth Pro. So can you provide us their KML files, or can you tell us their exact lat longs so that we can view by ourselves?
Yes. Give me a second. I will fire it up again.
No problem. You can send us later. You carry on
Yeah.
your.
What I can do, Ahmed, I can take all
Okay.
the
Okay.
details and
Actually, it was actually my bad. You could on the bottom, right here. I fired it up. It's okay. So yep. Over here, let me share this window. So yeah, like, so for example, this particular volcano, right? So you can see the different. You can see the image date. You can see the lat longs of this particular area, right? But for the most part, this particular search engine is just like your Google Maps, or the traditional search engine. So you can just search up different areas. So again, I will be talking about the geocoding API, where different places are actually placed on towards the particular lat longs. So Gildingadara, for example, is over here. You can see over here the lat longs over here. All right, so let's move back towards the presentation. So hopefully you can see. All right, so yeah, let's now talk about Google Maps platform. So yeah, so the Google Maps platform is actually more than just your traditional Google Maps that we use, right? To go to our favorite restaurant, or an area of leisure. So Google Apps platform perhaps is, I think, one of the most underrated, segments of or products by Google. Your everyday apps like Grubhub or Uber Eats, Uber or Lyft actually utilizes the Google Maps API. So where our everyday apps are examples of GIS, for example, in motion. So we don't tend to realize that we're actually using, again, satellite imagery based products or determined products in our everyday lives. But I will be focusing on a few APIs over here, particularly the environment APIs in the Google Maps platform. So let's not talk about the Google Maps platform air quality API, and let's have you can actually go towards the air quality API demo, and you can actually play it around yourself. Let me share this tab. Hopefully you can see. So let's fire this up. And over here, as I mentioned, when I was showing you around Gildingadare, you can actually detect gases, right? So using satellite imagery, for the most part, many countries are supported. Let's go down to Saudi Arabia, for example. This is quite quite polluted over here. So on the Google Maps platform, onto this particular API. Hold on, everyone. Give me a second, 1 minute. Yep. Can you hear me? Am I audible?
yes.
Right. Coming back. So the air quality API is actually fine-tuned towards different thermal imagery data, and you can actually detect ozone and various other pollutants using satellite imagery. For example, this particular area, let's click towards it. Um, it should be actually showing different. Yeah. I think the current air quality is poor down in central Saudi Arabia. Let's go to Riyadh, for example. Um, well, I think for some reason it's all broken, but it actually shows you real time air quality. You could say data. Let's say, for example, you can see carbon monoxide, you can see nitrogen oxide, you can see ozone, you can see different even aerosol particles and even sulfur dioxide, and it even gives you health recommendations. So you can actually utilize these APIs onto various different apps and whatnot. And yep, so it fired up, and you can see that the air quality is quite poor in this particular area. So the dominant pollutant is PM10. This is of course another aerosol. You can even see in real time the forecasts. Again, this is the model is being fine tuned towards historical temporal based data, particularly Sentinel 5P. So Sentinel 5P is an open source satellite imagery data by the European Space Agency that predominantly focuses on gases that are being emitted in the environment. So that particular Sentinel 5P data is available on the Google Earth Engine, and it is global. So global coverage of various pollutants can actually be detected. Let's go back to the slides over here. So yeah, so that was the air quality API demo. So hopefully now you're realizing, the audience realizing that the different opportunities of satellite imagery data. And I'd like to shed light towards the Earth observation market opportunity. So this is actually by the World Economic Forum, and within this particular report, the executive summary states that potentially there are more than $3.8 trillion of economic benefit that can be extracted from Earth observation-based data from 2023 onwards on towards 2030. And currently, the market cap of the Earth is about $300 billion, which is was poised to grow upwards of $700 billion by the end of 2030, while also positively, contributing towards as well. Talk about Google research, where things will get a bit interesting. I would say Google Research and the Google Research division, Google, is perhaps one of the most influential divisions there is. So what if I told you that one research paper started it all, right? So the Google developer groups, for example, Google Maps or Google Earth, everything, it all started from one research paper. And that was, of course, by the co-founders of Google, Sergey Brin and Larry Page. Their PhD thesis actually proposed the search engine that we used today, which is, of course, is at risk with the rise of generative AI. So the traditional search engine, of course, is being deemed outdated, for example, with the rise of generative AI. But again, it is amazing that this particular platform and Meet, for example, one research paper. So that is how significant this particular division is. I'd like to also share about another Google research that is going on right now. Is very relevant to something that has happened. So seen different wildfires spread across the California region of Paladesis, if I'm not wrong, and Google actually is working on something called as FireSat, where in 2025, where there are different satellites or constellation of satellites, which will give global coverage on a spatial resolution of, as you can see over here in this particular tile, that an area 25 meters, the size of a classroom, can actually be detected and local authorities can be notified of a wildfire taking place in 13 minutes. So the temperature is not one day, it is in minutes. So that is how many satellites are being launched. So there's lots of satellites being launched starting 25. I think it is very relevant to patterns that we're see, and of course this is something that let's also talk about another Google data set, 2.5T. And yeah, so let's explore this particular research over here. As you can see over here, so this is an Earth Engine app. We will be talking about the Earth Engine after. So the 2.5T is actually it is a compilation of different housing data globally. So over here, or for the most part, most regions. So low resolution Sentinel-2 data is actually been used, and different segmenting models have actually segmented different various buildings. So let's go down to let's say, for example, let's go down to Mexico, and here you can let's zoom into some area of interest, and you can actually see in very high fidelity various houses and buildings have been segmented. Now you must be wondering where this particular data set could actually be used. Well, there are different types of use cases, or you could say, for example, in terms of market intelligence, these are the number of houses your product, for example, could be marketed to. Forbid, if there is a natural disaster or a flood, for example, you can actually determine if this particular area is flooded, how many houses have been affected. Temporal scale, you can have different urbanization patterns that can be detected. So most areas from the temporal scale of 2016 on towards 2023, you can see different buildings, and again, this particular data set is very valuable. Again, the optic towards of view from this data set, it really depends on your use case. Any questions so far?
I don't see any, but please feel free to unmute yourselves, raise hand, or just put the question in the chat, and it should be okay.
Yep. So I would always prefer to have my sessions very dynamic. I know this is a bit unconventional what I am presenting today. It's not, again, this is of course unique stuff, or different things that you don't get to hear every day. But nonetheless, it's also very fascinating, the opportunity as a whole the geospatial industry or the Earth observation industry brings. Hopefully, some of you are inspired by this particular use case, and you say lots of opportunities, as I mentioned, as I'm showcasing it to you. But there are less GIS developers in numbers out there. So of course, a core element of why I'm presenting today is also to get your attention towards this particular area, and of course have it. I can see a few questions John has asked. So are there classification standards attached to each of these data sets? Something like scale buckets or material characterization? Yes. So let's say, for example, if you're inferring towards the open buildings data set, so over here you can see this particular research which has been published. This is a really good paper, has been cited quite a lot of times. Again, from satellite imagery. So in terms of your question, so the the benchmarks is also stated within this paper. So yes, it is a good idea to have a standardized way of moving a different data sets. But again, in the geospatial world, there are thousands of data sets that we can actually work with. So yes, there are certain standardizations in terms of, let's say, for example, the spatial resolution of a particular image. For example, in Sentinel-2, the spatial resolution is about 30 meters, if I'm not mistaken. So these are the different standardized ways of having, okay, this is the particular spatial resolution, so we can segment different buildings rather efficiently, rather than having a lower or a sparse spatial resolution or a high spatial resolution. So lower is better in our case. So, for example, there was actually a satellite imagery that I'm working on. So I've been talking about spatial resolutions for 30 meters, 50 meters, 1 meter spatial resolution. So there are satellite imagery present currently that go. So there are spatial resolutions in the centimeter as well. So I was at a park. You actually see the headline of my newspaper from 300 kilometers from space. So a high spatial resolution. So that is how crazy certain sensors have become, and they're also live feed data now. So in real time. So these are like images, right? So these are image tiles, right? So there's also active live feed data, but of course those sort of data I have not seen myself personally, but I am aware that they exist. They're strictly military based data. So yeah, so live feed data actually exists. So there's another question: can you access Open Buildings dataset through the Earth Engine API, or you need to use external APIs? So yes. So within the Earth Engine data catalog, there is a dataset, the Open Buildings dataset within the Earth Engine data catalog, so you can access it directly from there. Yeah. So yeah, let's move on. We'll now be talking about the Google Earth Engine. Google Earth Engine is, you can say, it's very underrated. It's lots of people that I come across, they've probably heard about Google Earth, but the Google Earth Engine is something that we should definitely have a look. So the Google Earth is a cloud platform where satellite imagery data is present, and each and every single day is updated on towards the historical, temporal, and not just satellite imagery data is present, but various different data sets that you can overlay onto words, as I was mentioning earlier. So there are different surface temperature data, climatic data, and so much more. If you go towards earthengine.google.com, you can see that within the datasets section, you can see the different types of satellite imagery present. So there's Landsat, going way back to 1972 with 30 meter resolution and Sentinel data. There's other high resolution imagery as well, as I was mentioning, some private companies like Planet or Airbus or Max. Those images have also been to provide us with those images on towards this platform, and this is, of course, is also a constellation by NASA as well. So some data sets that I was talking about earlier. So an optical image tile wouldn't make a whole lot of sense without having different data sets. So having meaningful extraction or geospatial analysis from an image is far more valuable rather than seeing an optical image, for example. So there's another there's a Canada-based crop inventory. So various types of crops is actually segmented in this particular data set. So there are, I'm not even joking. There are data sets that I have probably seen for the first time. You know, it is inhumanly possible to go through all these different data sets. So you can go on and on. So like, for example, so there's a data set for different topographies. What else? World settlement footprints. Again, I'm exploring some data sets along with you guys over here. So, oh yeah, so Era 5 data set. This is a very interesting data set. So this is actually, so this is a global data set. So you can actually see, let's open a particular data set over here. So you can actually see, use it in real time through the code editor, which I will be showing you in a minute. So the Era data set, so there are various bands, as I was saying. So within the electromagnetic spectrum, there are various different spectrums and bands that have a particular spectral signature or a spectral significance. So within this data, you can actually see the air temperature, you even see the precipitation, and these are the units. And you can even calculate the surface pressure. And of course, mind you, this is a global data set. So you can have very powerful geospatial analysis, again, on the fly, on the browser itself, on Google Earth Engine. So coming back, so again, we just explored the data catalog together. So again, this platform is quite interesting. It really depends on your area of interest or particular analysis. You, let's say, for example, are an ergonomist who is working in the agriculture sector. There are various different crop-based data sets that you could use if you are, let's say, for example, a climate activist. Even if you're a journalist, for example, you can actually use Earth to cross-verify and whatnot. So again, in terms of geointelligence, for example, again, there are milged applications. Well, there's just counterpoint, again, as I was mentioning earlier, there's just so many different cross sections that you can actually use satellite imagery data from and have overlaid the geospatial data sets to really make sense of your analysis. So yeah. So to use the Google Earth Engine, you either need to have JavaScript knowledge within the code editor. You can also have it. You can also utilize the Earth Engine API and use Python as well. You can also utilize the REST API as well. So which again can actually be a limitation. So so you would actually need to know. Let's now fire up the Earth Engine code editor, as you can see over here. So this is the IDE. This is you can actually write the different JavaScript code, and this is the base map. So this can actually be a limitation. For example, if one is not well aware of the built-in functions of JavaScript. So again, this is where generative AI comes in, right? So we're in the era of generative, where workflows are being automated and is getting easier. So we thought, again, we started searching for different cross sections of this particular interest. So we actually found a few on this particular area of interest where this is actually a foundational research, which actually coined this term of a GeoLLM, where using the paid APIs of ChatGPT, I think this particular research, this was published in the summer of 2024, if I'm not mistaken. This actually determined how well ChatGPT 3, for example, knows about various GIS concepts. And this is, of course, another paper where again, paid APIs are being utilized for GIS. So we again determined that for the most GDGoCs that are present currently in the market, they're all using paid APIs, and there isn't like a domain-specific model for the Google Earth Engine, right? So again, this then, you know, became that can we actually use an open source large language model and fully realize and utilize this multi-petabyte resource that is on the Google Earth Engine, and also and also give ease of accessibility to everyone using an open source AI model. So with every AI research, the biggest limitation is compute. You need lots of GPUs. You need lots of again, you need compute to make something useful, right? So but again, there are various other techniques of making less computational based AI research as well. But again, stemming back, so going back to 2000 and the summer of 2024, Gemma 2 was actually released. And within this website, if you would have gone back then, when Gemma 2 was actually released, so there was a research section where the Gemma academic program was actually open for different proposals. So whatever I just said a minute ago, we compiled a project proposal and we sent it down to Google, and the next thing you know, we got it. So we're actually working alongside Google, and we're actually the recipient of the GEMA academic program, and we're working alongside Google DeepMind for this particular research. Again, I can see some questions on the left. Again, these grants are open. Again, it really depends on which particular program that you're working on. And there are various, and it's just not limited to Google, for example. There are various other grants from, let's say, from AWS, from Amazon, or from Meta. It really is about positioning yourself in a way of having an exciting project or an interesting use case, for example. So this actually became actually the first generative AI from Islam. We're very excited to be working on this particular GeoAI research. So this is, of course, my supervising professor, Dr. Sajid, and of course my thesis partner, Hanzala. We three are on this particular Google research. And yeah, Google DeepMind, we're working, of course, on the Gemma open models, and of course I'd also like to shed light on this particular research paper, where you can really determine really good insights of Gemma 2 as a whole. I think Gemma 2 is also a very underrated open source large language model. It may not be it may not be in terms of benchmarking, of course. These benchmarks are also a gray area. We're seeing the best of the best models, and this is the best benchmark of, let's say, for example, 3.7 Sonnet, or this model, or Gemini 2.0. I think standardized benchmarking is something that LLMs are lacking currently. But of course, this is ever so evolving. So hopefully we will be moving towards a way of really benchmarking LLMs. I think, in my personal opinion, it is still a gray area. Lots of models and lots of companies right now, including OpenAI and all companies, actually fine-tune their models onto data sets. So you can actually artificially bump your particular benchmarks, for example, in reasoning, in terms of math, and coding abilities as well. But nonetheless, coming back to the topic in hand. So yeah, Google DeepMind is, I think, one of the most influential AI research labs out there. They're actually, they actually won the Nobel Peace Prize in chemistry in 2024, at the end of 2024, for AlphaFold. So I'd like to also shed light on AlphaFold as well. So this is a model which are being used by millions of researchers worldwide, where you can actually predict a protein structures of various kinds. So everything around us has a particular protein structure. So you can actually, for example, determine protein structures of plastic, for example. So having the protein structure, molecules being simulated, you can actually develop catalyst that can actually eat up those particular proteins and molecules, right? So you can, for example, sea pollution, right? So oceanic pollution, for example. So this is a very groundbreaking research, and kudos to the team there at Google DeepMind. So yeah, now let's move towards a live demo of our particular Google research. Hopefully you can all see my screen over here.
Yes.
I will be showcasing our particular research over here, and yes, the applications, of course, they are closed right now, but again, Google comes up with. You can actually go down to google.org, and you can see different opportunities down at Google as well. So you can actually have a quick Google. There are certain programs open right now for students as well as for developers out there that are open your back to this particular notebook. So yeah, over here, let's run these, and let's reconnect to the GPUs that Google provides in this particular. Well, this is a free tier Google, so this is not Google Pro. This is not Colab Pro. So yeah, so we've now fired up a T4 running in the background. Let's run this code. So let me just walk you through this code. So right now we will be inferencing a 2 billion parameter model using Olama. So Olama is a framework where you can actually locally run a large language model. It really depends on your systems or how much compute or GPUs that you have running in parallel. Over here, what we're able to do is we're running Olama locally on towards a Google Lab Colab notebook, and we will be then calling Olama onto the T4 GPU over here. So yeah, so right now we are inferencing our model. So as it happens, so this will take like a minute or two while it happens. So how's it feeling so far? Like what have you been able to grasp? Hopefully you're now starting to learn. Okay, this particular area is quite interesting. This is unique. So I'll be happy to take questions. You can open up your mic and ask away.
Yep, definitely. I do see some questions. It's like I'm not sure if the question. Most free versions exist. The full data history is limited, but recent history might be available. Paid versions usually offer more extensive tracking. Okay, not that. Um,
So the question,
Right. So
will we share the notebook, this notebook, or is it closed? I mean, the code of the notebook.
Actually, this is actually this is in progress right now. So I unfortunately would not be sharing this notebook as of now, but during late April we'll be sharing again our model, and of course most code open source. This is a very of what we are actually working on. So we're very actually successfully, if I could give you a current update, we actually successfully have been able to using an LLM, using natural language processing, we are able to successfully navigate through all of the data sets, 1,031 data sets. I checked earlier today. Yes, about 1,031 data sets currently on the Earth Engine data catalog. So right now, using a stack architecture, we've able, and of course, a RAG architecture, we've able to successfully parse or access all of the Earth Engine data. So I think over here, this particular model, I think we've been able to successfully pull the whole model. So the model is actually running locally on towards the GPU provided. So over here we've been able to initialize or call the Earth Engine API, and let's move towards this particular code section over here. Over here, this is where the agentic work is being done. So we're calling different libraries to visualize, to create a map GUI for us to see, and we're also, of course, this is where LangChain is being utilized. So in this particular demonstration, we've able to pick up 3 different use cases. So in this particular again, as I mentioned, this particular demonstration, so yeah, it's running successfully, and this is the map GeoAI. So this is map UI. Sorry, and we will be able to access the vegetation index. So using again LangChain. So again, this is a proof of concept, right? So we will be seeing 3 different use cases. So we will be accessing an RGB image, an optical image worldwide, using natural language, using a prompt, and we will be also seeing the different vegetation indexes, which is very crucial for agriculture. We will also seeing water bodies. So there are 3 functionalities right now, as of now, within this notebook that we will be seeing. So let's prompt. So give me the NDVI, which is the vegetation index, normalized difference vegetation index of, let's say, for example, Toronto, Canada, right? Totally works. Yep. So yeah, it has successfully able to navigate, and you can see over here. So this is the NDVI of Toronto, Canada. You can see how the different green areas are being seen. So let's go back. Let's say, for example, give me the RGB image of Dubai, UAE. So I was actually born and raised in Dubai, UAE. I've lived there pretty much. So this is a Sentinel-2 date image of Dubai, UAE, for example. So yeah, so the things are running pretty well. So you can see through the this is not a fine-tuned version of Gemma, mind you. So this is quite interesting. So this is a standard version of Gemma 2 billion running in a single Colab notebook. We've able to call in the Earth Engine API, and of course through LangChain, we've able to have different function calling, and we're able to have different buckets of different types of geospatial analysis. For example, the NDVI or the RGB image in a single Colab notebook. So again, the standard 2 billion model is being utilized. So the 2 billion model actually has been trained on towards different geographical coordinates. Geographical coordinates is absolutely crucial for us to determine or go towards an area of interest, right? So let's say, for example, if I ask, give me the water bodies. This is the third functionality of Islamabad. So yeah, so here, as you can see over here, it has able to extract different water bodies that is present within Islamabad. So yeah, so there you have it. So this is actually part of the Gemmaverse initiative by Google DeepMind. You can actually see different use cases on towards Gemma. So we're calling our model GeoGemma, which we will be releasing next month actually. So do have a look out. You can. I will be sharing this particular update through to the social media channels and down at GDGoC as well. And yeah, so that brings the end of our sessions. Hopefully, you have now explored the significance of satellite imagery, and you've also dived into alternative Google geospatial products, and of course you've now know about a Google funded research happening on GeoAI. So you can follow us on our socials, and you can also follow GDGoC as well. And that is it from my side. I can again happily take questions.
Thank you so much. I see a couple of questions.
Yeah.
Can I access Open Buildings data directly through the Earth Engine API, or do I need to use external APIs?
I'm sorry. Could you repeat this question?
Yes. I'll put it in there. Okay. Can I access Open Buildings data directly through the Earth Engine API, or do I
Yes.
need to use external APIs?
Yes, so you can actually utilize the Open Building dataset as is in both the Earth Engine environment and separately. You can actually utilize the dataset on towards local. You can say geospatial softwares like, for example, Esri, right? Esri's ArcGIS is that particular open data set. Again, locally on towards other geospatial platforms or within Google Earth Engine directly in the IDE. You can also, of course, use the API as I have in the Python environment. So yeah, how often the Open Buildings data set is updated, that I'm not aware of. That is something, of course, we could probably reach out to Google about that. You can definitely throw in an email. Their Earth Engine team is based in Seattle actually. So predominantly the Earth Engine and the Google Earth, or the Google for Geo division, is based in Seattle. Of course, we're coordinating with them. So we're again within this Google research, we tend to have bi-weekly or tri-weekly calls with the folks down at Google Earth as well as Google DeepMind. So yeah, to answer your question, again, you can utilize both within the Earth Engine IDE, and you can also call it from the API. You can also have this data set as a standalone in other geospatial software as well. You can, of course, you can search Open Buildings dataset 2.5D to know more.
Perfect. Another question, and I'm pinning the question so that you get to easily follow them. How often is Open Buildings data?
Yeah, but I've answered that. So I'm not aware. I'm not aware. I think for the most part, it has been updated up until 2023 from 2016. Yeah, 2016 to 2023 onwards.
Perfect.
I think Ahmed has another question. You said GPU is important, and I'm running the model locally. Yes. So the specs, right? So it really depends on the model that you're using. For example, a model like Gemma, right? So the 2 billion model is about 1.8, 1.6 GB, about 2 GB in size. So that is more or less manageable by most laptops, or yeah, you can even run it on a phone as well. That is what it exists for. But again, you can explore different quantization techniques that can be really interesting. You can actually quantize a larger model so that it can fit on towards your GPUs that are mostly accessible. So you can definitely look into quantization methods to have to solve your problem. So again, the answer to your question is again, it really is subjective. You can have multiple GPUs lined up in parallel running your models, or you can have a single GPU. It really depends on your particular your use case, and yeah. Yep. Is there any questions? Any other questions?
Just about the notebook, I think we all wants to get hands on this notebook, but as you said, you're not sharing this one.
Yes,
Would it be?
yes, yes. About the notebook, the thing is, within April, we this is a very primarily, you can say showcase of how you can actually use LangChain, using the Earth Engine API, and running the model locally in a Colab notebook. So this is, okay, it might be basic stuff for me. It may be, something new and exciting for the audience member over here. But again, not to actually, within you can actually expect an update in March, in mid of March, where we're actually in talks with Google to have something called as the Earth Engine Playground, being hosted. So we would want globally everyone to use this particular use case, and just prompt around the whole globe or the whole planet. So yeah, you can expect again, this research is open source, so I have nothing to hide, for example, right? So I can actually send this notebook, no problem. But the thing is that we right, there should be a certain threshold of things being released, right?
Yeah,
So
perfect.
you
What
can expect an update really soon on our channels on GitHub, for example.
Awesome. So we'll wait for the playground, and
Yep.
I'll
Yep.
personally try to get in touch with you and get more
Sure.
updates, and then share with our community members too.
Sure.
Having said that, I would definitely still leave a request with you to at least share a starter template with us, which does
Sure.
not compromise your work, but
Yeah.
still we all have a starter template, so that we take this knowledge that we just got from this session,
Yeah.
and we try to tinker around things. And I think that's how it is. We just got curious about the entire
Yes.
thing, and now we want to go back and use something
Certainly.
in different
Not,
ways.
not, now that you've mentioned it, I'll have something sent to you. Yeah.
Oh,
Sure.
thank you so much. So that's one thing. But I have a question about, because I have been looking at NASA's Earth data. I
Okay.
do know that AWS and Microsoft, they also have their own
Yes. Yes.
right data sets, and all of them have different pros and cons when from the usability purpose. um, did you get a chance to look into the NASA's Earth data at any point? Because what I feel, right now, when you showed the Geo AI, sorry, the Google Earth Engine, I felt
Yes.
that they have AI ML, like Google AI is working, and you said that you can also check the predictions, right?
Yes. Yeah.
So you said there was advanced image analysis on
Yes.
masking on the clouds, and
Yes.
imaging and other things. But with NASA's, while we get I think more data set, like there is not limit on it, but it's not very much self-explanatory, or it doesn't make it easy for somebody new to understand
Yes.
it, right? So if you experience something like that, or if you know the best ways to get NASA's data and work with it, um, what
Yes. So you've been mentioning of different imagery data of NASA, right? So, for example, you also mentioned about Microsoft and AWS. So there's also something called as the Microsoft Planetary computer. So it's very similar to the architecture or the use case of Google Earth Engine. But Google Earth Engine has been around for quite some time. It has been around since, I think, 2018. So yeah, it's been around for quite a while. This actually was also a research, a PhD research of having big geospatial data on the cloud. So from this particular research, Google actually run and actually created a platform. To answer your question specifically, I would I wouldn't want to sound biased, but the easiest way of accessing different various types of imagery tiles from NASA, or again, NASA has so many different constellations and so many different missions which are open source. We talked about MODIS, we talked about Landsat. There are other geospatial, you could say, authorities out there, like for example NOAA, which has been in the headlines quite recently as well. And there's also USGS, which is the US Geological Survey of the United States. Those particular authorities have global levels of their own. But again, my bias is towards Google Earth Engine. It is the easiest to access on the fly those images or data sets. If we talk about the different imaging sources from USGS or NASA directly, or the Data Explorer, for example, you actually are quite restricted on towards single image tiles in some examples. So you have to actually download, and then you have to also pre-process that particular image and then overlay different data sets. So that becomes very counterintuitive. So on the go, in real time and globally, you can actually use Google Earth Engine. So I think again, it becomes really easy on that. Is why I think it is one of the most underrated products out there.
No, definitely, by the looks of it and how you explained, it makes more sense for my personal project, which is towards dump site and the gas emission from them, and how it impacts the soil around the
Very
dump
interesting.
sites and
Very
the air
interesting.
quality.
Actually, there is a researcher that I know about who's actually working on wastage. We're just buying up stuff, right? So we just throw it away. Where is away, right? So this is a very food for thought for the audience over here. So we're actually having different consumer. We're like consuming different products, clothes, for example. I was reading this particular H&M, which is a clothing brand, I think, based in Europe, actually produces millions of garments per day.
Right.
So we just throw it away, right? So having the supply chain of
Oh, we lost you.
waste, and you can actually utilize again. This is
Yeah, we lost you there for a couple of for a couple of sentences, but yes, coming back to it, I think this gives a better idea. And I'm not a GIS developer, so I was struggling on how do you actually use the database itself to start with. But this makes it easier, and I hope it makes it easier for others too. So what I'll do, I'll stop recording and we can stay for a while and discuss other things. But thank you so much, everybody, for joining today. Thanks to Google Developer Groups on Campus IST, Abdullah, Ahmed, for joining us. This is not the ideal time. It's not day for you, but you still joined us, and this is amazing. Thanks everybody else joining us today. I'll stop the recording, but we continue discussing if you want to. I'm here, but it's too late for you. Then we'll see you again.
It's all good. It's all good. I think one concluding remark that I can give: you can actually utilize the Google AI Studio out there, and you can use the Gemini 2.0 Flash, and they're giving you a context window of about 1 million something tokens, which basically is like a free tier, a very good model. On the free tier, you could say utilize on towards the AI Studio. You can use it pretty much all day, and it won't give up on you. You can actually utilize that particular model and the IDE of Google Earth Engine. So you can just prompt your way iteratively. You can copy paste the different codes that it generates, and you can have you can say you can say geospatial analysis on the go utilizing Gemini 2.0 Flash. It's fine-tuned pretty well on Earth Engine datasets. Yeah.